All right. So in chapter 12, we talked all about the law of sines. So something like A over sine of A equals B over sine of B equals C over sine of C. Now we use these for a few different kinds of triangles, but let's say we wanted to use this for a triangle that was side, angle, side. So if we look at exercise 13.1, where they say angle B is 30 degrees, side A is 10, so we'll call this angle A. Side C is 12, so we'll call this angle C, and we don't know what side length B is. Now, if we wanted to use the law of sines, then we have A is 10, so this is 10. I don't know angle A. I don't know side length B. Angle B is 30 degrees. And I know side length C is 12, but I don't know sine of C. So now in order to figure this out, I need to know either angle A, angle C, or side length B. Well, can I figure out angle A from what I have right here? Well, I only know angle B is 30. So without angle C, I can't get angle A. And without angle A, I can't get angle C. Additionally, I can't get side length B until I have either angle A or angle C. So from the law of sines, I am entirely stuck. I can't make any progress with the law of sines. Now, this, with a triangle that looks like side angle side, is where what we have called the law of cosines can come into play. Now, the law of cosines starts out a lot like the Pythagorean theorem. So if we remember the Pythagorean theorem is c squared equals a squared plus b squared. Now the law of cosines starts out like this. We have c squared is equal to a squared plus b squared minus 2 times a times c times cosine of angle C. So we can tell this starts off like the Pythagorean theorem, but then we have to tack on this extra bit. And this is true for any triangle, for an oblique triangle. So whether we're a right triangle or not, we know what the angles are or we have no idea, the law of cosines is still always going to be true. But again, with an oblique triangle, the way that we name our angles is pretty arbitrary, our angles and sides and whatnot. So it turns out that we actually get 3 versions of this for whichever side we're looking at. B squared is a squared plus c squared minus 2 ac times cosine of angle B. And side A squared is b squared plus c squared minus 2 bc cosine of angle A. So now, based on the law of cosines, can I solve this? Well, sure. I need to know side length B. Well, b squared is equal to a squared plus c squared minus 2ac cosine of B. But it turns out that I know AC and angle B. So B squared is equal to 10 squared plus 12 squared minus 2 times 10 times 12 times cosine of 30 degrees. Where now everything on the right-hand side of the equation is something that I know. In fact, let's clear up this space so we can simplify this and figure this out. Now, I keep erasing. now I can say that b squared is equal to 100 plus 144. 2 times 10 is 20. Sorry, we'll do 2 times 12 is 24, times 10 is 240, times cosine of 30 degrees. And now this is the point where cosine of 30 is root 3 over 2, which we know exactly that number, but we don't really know how to take square roots in a nice way. So I'm not going to bother trying to do this in any exact way. Now I'm going to start rounding things out. So I can go to my calculator and I can type in cosine of 30 times 240 gives me about, well, I'll go ahead and add 100 to 144. I say that's 244 minus 207.846. And then when we do that math, this gives us, hold on, I did that wrong. 244 minus 207.846 gives us about 36.154. So if b squared is about this, then b is about the square root of 36.154, which we can take that square root in our calculator, and this rounds to about 6.013. So now I know side length b is 6.013. So now that I know side length b, if we looked back at what I erased earlier for the law of sines, we certainly should be able to use the law of sines to figure out what angle C or angle A are supposed to be. But I think we also are able to figure out what A and C are supposed to be using the law of cosines. So we can take a second and digest this work and make sure that everything we did was correct. So the law of cosines says that b squared is equal to a squared plus c squared minus 2ac times cosine of b. Why did I want to use that? Well, because I have side, angle, side. I have side A, angle B, and side C, which is exactly everything I need to figure out what b squared, aka b, is supposed to be. Not that b squared is the same as b, but if I know b squared, then I can figure out what b is by just taking that square root. So I do that, I plug everything I know in, and then I simplify this down in my calculator, and I just get this that I take the square root of. Very good. So if we clear up some room, I still need to figure out what angle A and angle B are supposed to be. Well, here, sorry, angle A and angle C. I need to know what angle A and angle C are supposed to be. Well, if I write down my law of cosine again, for A, I have that a squared is b squared plus c squared minus 2ac times cosine of angle A. Well, what do I know in this equation? I know side length A is 10. B, I just figured out, is 6.013. And it told me C is 12. Sorry, I miswrote that. It should be B times C right there. So B, again, is 6.013 times side length C is 12 times cosine of angle A. Well, now I can figure out exactly what these numbers are. So this is 100. This is 36.154. This is 144. And this is Negative 2 times 6.013 times 12 should give me negative 144.0308 times cosine of A. So now I can subtract these parts from both sides so that I get 100 minus 36.154 minus 144 is equal to negative 144.308 times cosine of A. But this left-hand side simplifies. Subtract 36.154 and then subtract 144. And this gives me negative 80. Once we do 100 minus 36.154, I typed that in wrong. 100 minus 36.154 minus 144, we get negative 80.154 is equal to negative 144.308 times cosine of A. Now I can divide both sides by this negative 144.038 or 308 to get cosine of A by itself. So once we do this, this turns out to negative 80.154 divided by negative 144.308. And this turns out to be about 0.555 if I'm rounding to 3 places. So now if I know that cosine of A is 0.555, is there anything my calculator can do that gives me A? Absolutely, that's just our cosine inverse. So A should be cosine inverse of 0.555, which turns out to be about 56.259 degrees. Now, if you got something that's a little bit off, I think earlier I got like a slightly different decimal for this part, which would mean the decimals here are a little bit different. That's not a big deal. I may have just typed a decimal in wrong somewhere along the way. But either way, this, if your number is close to this, then that's good. I think I might be a little bit off this time. But this is what the answer looks like. Just off by maybe 1/100 of a decimal, maybe. Okay. Now you should be asking yourself, well, maybe not should, but you might be asking yourself, why are we not talking about the second possible angle? When we did law of cosines, and we looked at cosine inverse, when we did law of sines, and we looked at sine inverse, then looking at the unit circle, sine inverse only gave me answers from negative 90 up to 90. Well, cosine inverse that we just used gives us answers from 0 to 180. So with sine inverse, we weren't able to figure out if an answer was in quadrant 2, if there was an angle bigger than 90 degrees. But for cosine inverse, we get every angle from 0 to 180, and there is only one of that angle. So when we use the law of cosines, we don't have an ambiguous case. There are not 2 possible angles. When we do law of cosines, there is one solution. There is one possible angle. And in this case, it is exactly this angle for A, which now means if I have that angle A is about 56.259 degrees, then can I figure out angle C? Well, I already have angle B and angle A. So angle C should be 180 minus 30 minus 56.259. Sorry, I typed that in wrong again. So 180 minus 30 minus 56.259. And this gave me 93.741 degrees for angle C. So with the law of cosines, we were able to go from having side, angle, side to get missing side. Then we went from knowing all three sides to getting the missing angle. So we can kind of break all of our cases up between the law of sines and the law of cosines. So if I have angle, side, angle, or angle, angle, side, or let me turn back, side, side, angle, these are the ones where we use the law of sines. But for the law of cosines, we use that one for side, angle, side, or side, side, side. Now, if I have angle, angle, side, then I can use that to, sorry, I don't know why I went in that order. If I have angle, side, angle, then I can find missing side. So then I can just on my own find the missing angle and find the missing two sides. And the exact same thing happens with angle, angle, side. Find the missing angle, use those to find the missing two sides. And then for side, side, angle, then I have ambiguous case. Where I find the missing angle, I potentially get a second triangle, and then I use the rest of it to solve the missing sides, the remaining missing side. Whereas the law of cosines, I can solve for the missing side, then solve for the missing angle, and either approach that we want to from there. Okay, so very good. This is a really good example for the law of cosines, both in solving for missing sides and solving for missing angles. So absolutely go through the workbook and practice all the way through 13.3 and make sure that you're able to use this and look at these there. Okay, very good.